Question number 29. Two progressive waves of equal amplitudes and equal frequency move in opposite directions along a string. They interfere to produce a standing wave having the equation y is equals to a cos x sin omega t. The value of a is given, k is given, omega is given. We have to find the value of velocity of the progressive wave is. Okay, it is simple. V is equals to omega by k. Value of omega is given as 78, sorry, 78.5, and the value of k is 1.57. Finally, we will have centimeter per second. Centimeter per second. See the value 78.5 divided by 1.57. Correct. So definitely this will not give 42 meter per second. This is centimeter per second. And here meter per second, but the value is 42. Definitely it will not that much. Here 44, 45 meter per second. So this will not be the correct answer. Our correct answer will be option A. And if you calculate it, you will get really 50 centimeter per second. It is solution of question 1. Now let's move to solution 2. The node closest to the origin in the region x greater than 0. So we have to find the value, we have to find the points where the nodes are situated. Nodes means the amplitude or the displacement will be 0 at all the time. For that, a cos x should be 0. Correct. That is cos kx have to 0 for node. Correct. Okay, when this will be 0, when the value of kx will be pi by 2, 3 pi by 2, 5 pi by 2, and so on. Why not 2 into pi by 2, 4 pi by 2? Because they will give pi, 2 pi, and for values of cos pi, sorry, cos, yes, for cos pi, cos 4 pi, this will give cos 4 pi, sorry, see, okay, let's check. If you write here 2 into pi by 2, this is basically pi, and cos pi is equals to -1. So this will not give 0. Correct. Similarly, if you choose 4 into pi by 2, this is actually 2 pi, and the cos 2 pi is equals to, as if cos 0, that is 1. Correct. So this will again not give 0. That is why for if kx is equals to pi by 2, 3 pi by 2, 5 pi by 2, then cos kx will be 0. Okay, so if we choose first this condition, kx is equals to pi by 2, kx is equals to pi by 2, x is equals to pi by 2 by k, and the value of k given in the question is 1.57. Correct. See, if you multiply 1.57 with 2, you'll get 3.14. Okay, and value of pi is again 3.14, that is you are getting 1 centimeter. Yes or no? Yes, sir. So this is the location or position of node. Now this is greater than 0. Yes or no? If you choose this condition, the value of x will be definitely greater than 1. So our correct answer is 1 centimeter. Okay, closest to the origin. Origin x is equal to 0, and we are getting a node at point x is equal to 1 centimeter. So the answer is 1 centimeter. Now let's move to question number 3. The antinode closest to the origin. For antinode, this value cos kx should be 1. For antinode. The amplitude is maximum at that point. When this cos kx will be 1, if kx is equals to, see the at antinode, the value of mod kx will be 1. So kx may be cos 0, yes or no? Kx, if kx is equal to 0, pi, 2 pi, 3 pi, 4 pi, for these values of kx, cos kx will be 1. Now, if we choose kx is equals to 0, then x will be 0. But we need the position of the antinode for x greater than 0. So let's choose the condition kx is equals to pi. Okay, kx is equals to pi. Kx is equals to pi. So x is equals to pi by k, and the value of k is 1.57. 1.57, and the value of pi is 3.14. So 3.14 divided by 1.57, this will give 2 centimeter. So our correct answer will be which one? 2 centimeter, option C. Okay, now let's move to question number 4. The amplitude of particle at x is equal to 2.33 centimeter. The amplitude of the particle at x is equal to 2.33 centimeter. Okay, let's have some space here. Amplitude, which one is amplitude? The amplitude part is a cos kx. A cos kx. The value of a is 1 millimeter. 1 cos kx. Value of k is given 1.57, and the value of x is also given at 2.33 centimeter. The unit is millimeter. Okay, cos 1.57 and 2.33. Correct. 1.57. 1.57 means pi by 2, and 2.33 means 7 by 3. Okay, so this is cos of, so I am writing here cos this one. Okay, so this is basically cos 7 pi by 6. We can write it as cos 7 pi by 6, that is pi plus, if we choose here pi by 6, check if it is correct or not. 6 7, yes, 7 pi by 6. So cos pi plus pi by 6, it will remain cos pi by 6. Correct. And cos pi by 6, that is cos 30 degree, and the value of cos 30 is equals to root 3 by 2. And the value of root 3, you have to remind it the value of root 3. This will help you. 1.732 by 2, and finally we will have 0.86 centimeter. Correct. So option D is correct. Now our next question is, what is the physical quantity symbolized by K? Okay, before that let me erase this to have some space. Okay, symbolized by K, you know K is 2 pi by lambda. We everyone know K is equals to 2 pi by lambda. K is equals to 2 pi by lambda. But what is the physical quantity? Okay, before that, see, you know F is frequency, and if you just multiply 2 pi with the frequency, you get angular frequency. This is frequency. And if you multiply 2 pi with frequency, we get angular frequency, correct? Similarly, 1 by lambda. 1 by lambda. What is 1 by lambda? This is number of wavelength. See, 1 by lambda. 1 by lambda. Number of wavelengths per unit length. What does it mean? Suppose this is a length. This is 1 meter. Okay, this is 1 meter. And suppose a wave is there. How much wavelength is there? 1, 2, 3, 4, 5, 6, suppose 7. In 1 meter length, there are 7 complete wavelengths. Okay. So, in this case, the 1 by lambda, the value of 1 by lambda will be 7. This is just an example. If there are 7 wavelengths in 1 meter, then the value of 1 by lambda is 7. The number of wavelengths per unit length. And the name of this quantity 1 by lambda is wave number. Okay. Now, we observed here that if you multiply 2 pi with frequency, then we get angular frequency. Similarly, if we multiply 2 pi with 1 by lambda, that is 2 pi by lambda, this is also angular. Here it was wave number. Angular wave number. Okay, keep it in mind. 2 pi by lambda is known as angular wave number, and 1 by lambda is known as wave number. 1 by lambda represents number of wavelengths per unit length. Okay.